Hello and welcome back to Anton Math. Now in the last video we talked about using truth tables to determine if two different sets are equal to each other. And in this video I want to show you that we can actually also use truth tables to determine if one set is a subset of another set. So I'm going to go ahead and make a little truth table and then we're going to start making some observations. I know I just did this in the linked last video, but it's good practice to make these truth tables. So let's say I have these three sets, A, B, and C. And I'm going to go ahead and set up my truth table differently, just different people like doing it different ways. I want to show that it's equivalent to do it two different ways. So instead of alternating my A, I'm going to have my A be the column that's 4 trues followed by 4 falses. I'll have my B the sequence of 2 trues and 2 falses. And my C is going to alternate between true and false. So we can see that this is equivalent to how I did it before. Really what's important here when we're setting up our truth table of sets or of propositions is that we're exhausting all of the different combinations of whatever our sets are. Here we have 3 sets, so I want to exhaust all different combinations of true and false for these 3 sets. The order in which I list them is not really important. It's just going to change the order in which my compound sets come out, which is fine. So let's look at some sets. Let's look at A intersection B. Let's look at A union C. Let's look at the complement of A intersection with C. And let's look at the complement of A intersected with C union B. Okay, so we're going to go ahead and fill out this truth table, and then we're going to make some observations at the end that are going to let us see how we can find subsets in a truth table like this. So A intersection B, that's true whenever A and B are true and false otherwise, right? So these first two are going to be true because both A and B are true, and the rest of my terms I have either A is false or B is false, so I'm just going to have 6 falses. Now A union C is true if A is true or if C is true. So these first 4 are going to be true because A is true in the first 4 rows. And then after that we're just looking at C because A is going to be false. So it's going to be true, false, true, false. That's a true and false. Now A complement intersection C, we know A complement is true whenever A is false, right? And A complement is false whenever A is true. And so this is going to be true whenever A complement is true and C is true, or in other words, whenever A is false and C is true. Now these first 4 rows, A is true, so my A complement is going to be false. So my intersection then is going to be false. Now these next 4 rows, I'm going to have true whenever C is true and A is false, and false otherwise. So I'm going to have true, false, true, false. And for this last one, this is going to be true whenever B is true or A complement intersection C is true. So we have A complement intersection C here. Remember, we always want to build up to the more complicated ones, so it's easier to see now when this is going to be true. So it'll be true when this column is true or when my B column is true. So looking at B, I have true, true. In the next 2 rows, both of them are false. And looking at B again, I have true, true. And now looking at A complement intersection C, I have true, and then the last row, everything is false. Okay. So what does this tell us? Well, we know when we talk about a subset of a set means that if an element is in the first set, then it's in the second set, right? Then the first set would be a subset of the second set. So that corresponds to the truth tables in that if we have a truth column, let's look at A intersection B. if everywhere that A intersection B is true, I have another set that's also true, then A intersection B is going to be a subset of that set. So looking right here, I see A intersection B is a subset of A union C. Right? Because every time I have an element in A intersection B, that element is also in A union C. Notice I don't need A union C to be exactly the same, right? That's how we tell that two sets are the same set. When we're looking at subsets, I just need all the truth values here to correspond to truth values in the other set. Then this is going to be a subset of the other. Now this follows in line with our definition of two sets being equal, because they're going to be equal if they're both subsets of each other, right? If those truth values correspond exactly. Let me make a couple other observations. A complement intersection C is going to be a subset of A complement intersection C union B, right? Just looking at these last two columns, I see that everywhere that this column is true, it's also true here. So I have this subset relationship between these two sets. And there's lots of them here. A intersection B is a subset of A intersection B is a subset of B. A and C are both subsets of A union C. C is a subset of A complement union C, etc., etc. But this is generally how we would approach a problem where we want to find a subset and prove that something's a subset using a truth table. This is how we would do it.